Today we're going to talk about perimeter area and in correspondence with circle circumference. So maybe some of this might be review from middle school and maybe some of it might be new. But we are going to be doing some complicated problems later on throughout the year. So it's really important that we can understand our basics. So the first thing I actually like to talk about is what area is versus perimeter. So we'll start with a basic shape. We'll look at a rectangle here. Let me make a line a little thinner. And I'll draw the same rectangle down here a little bit. Ooh, that's not a very straight line. And we'll say let's let the sides be like 2, 2, 4, and 4. So when we think of perimeter, we think if I wanted to put a fence around this rectangle, how many, let's say, feet of fencing would I need? I would need 4 feet to cover this side, 2 feet here, 4 feet here, and 2 feet again. So when you find perimeter, it's as simple as just going around and adding each side together. That would count all the fencing that you would need to put around it. So if I add 4, 2, 4, and 2 again, I'm going to get 12. So in this case, my perimeter would be 12 feet. Area is a little bit different. So when we think of area, we think if you wanted to put carpet inside your bedroom, the way that it works is you would have to count how many square feet can your bedroom be broken into. So what you're really doing is, let's say this is feet, you're looking for how many 1 by 1 foot blocks or squares fit in here perfectly. So you could count them all up, or a shortcut is to realize, well, you have 2 going this way and 4 this way, so we just multiply 2 by 4 and we get 8 square feet. Now, I rate my square feet this way, but I know that you guys probably have done this that way in middle school, which is fine. Either one, they're the same thing. But that means that there's 8 of these squares inside the shape. So when we talk about area of a circle, as a reminder, our formula would be radius squared pi. And when we look at a circle, the radius starts in the center and goes towards the edge. If I want circumference of a circle, there's actually 2 formulas. I could do diameter times pi, or 2 times the radius times pi. Now, diameter would be the whole way across a circle. So if this is the center, diameter is going to be the whole way across. So if this was 10, I could say, oh, my circumference is just 10 pi. Or you could do 2 times the radius, which would be from here to here, and that would just be 5. But 2 times 5 gets you 10. So they're the same formula. Area would mean how much you have to fill in the circle. Circumference is just a fancy word for perimeter. So if you started here and you walked in a full circle around this circle here, and you count how long you walked, that's the circumference, that's a perimeter. So we'll just make a note that perimeter is distance around. And area is space within. Just to kind of keep that separated. So if I want to find the area and circumference, and it's a circle whose radius is 4, my area would simply be 4 squared pi, which is 16 pi. And my circumference, since I'm doing radius, would be 2 times the radius times pi. Well, 2 times 4 is 8, so it's just 8 pi. Now notice, I am not using 3.14 for pi. I actually want you to learn to leave pi in the answer. It's the most precise answer you can get, and it's a good way to make sure that everyone in the class has the exact same thing. So this time I'm going to give you the diameter. So since area is r squared pi, I need to divide 16 by 2 so I can get my radius. That would make it 8, which is just 64 pi. And for the circumference, I'm actually going to use the d pi formula since I know the diameter, and that will just be 16 pi. In the next example, we're going to actually work backwards. We're going to be given the circumference of a circle and have to extract information from that, get the area of that same circle. So let's just look at circumference formula again, since that's what we're given. And circumference, if you remember, is diameter times pi, or 2 times the radius times pi. To make things simple, I'll use the diameter times pi formula. So if I compare d pi to 18 pi, my diameter has to be 18. So if I turn my attention now to the task at hand, you're supposed to find the area of the circle, which is r squared pi. But we don't know the radius, we know the diameter. So in order to go from diameter to radius, you have to divide by 2. So this would be 9 squared pi, which comes out to 81 pi. If we were to look at this in a drawing, my diameter is 18, so you can see that halfway through that, or halfway from that, is the radius, which we got 9. So the distance around this is 18 pi, which is our circumference, and the amount of space within is 81 pi, so they are different numbers. In number 4, you have a pool that's 15 by 20, so we're going to go ahead and draw a rectangle and label the sides 20 and 15. And we are dealing with feet. So the thing about this pool is you want to build a 3-foot wide deck around it. So I actually like to draw a picture. It helps me avoid forgetting numbers. So if we kind of draw what that deck would look like, it would look something like that. And because it's 3 feet wide, we have to account for this extra room now. So there will be 3 feet from the edge of the fence to the edge of the pool, and that would be from all sides. So it's definitely worth it to go through and at least label 2 of your sides, so that we had a space of 3 here and a space of 3 here as well. So since we're talking about building a fence around the deck, I'm actually talking about perimeter. But I don't want to use just 15 because the deck really adds 3 feet both sides. So I'm actually looking to build a fence around, on the right side it would be 15 plus 3 plus 3, which is 21 feet. And on the other side, I know the pool is 20 feet long, but I also have 3 feet on either side. So this is actually 26 feet along the side here. Now you can go through and label the other 2 sides, but it's a rectangle, so we don't really need to do that. I know that I'm going to have 2 sides that are 21 feet and 2 sides that are 26 feet. So instead of adding 21 plus 21 plus 26 plus 26, let's just multiply by 2. It's a little bit quicker. So this would become 42. And this is 52. So it looks like I'm going to need to get 94 feet of fencing. In our last figure, you're supposed to find the area, so we're looking for how much space is inside of here. So the key is noticing that we have tick marks on all these sides, which means they are all 2 centimeters long. And if I really wanted to, I could just break this up into individual squares. So this would be 2, 2, and 2. That makes 6, so we know that that's okay. And 2, 2, and 2 makes 6 again. So probably the easiest way to do this is, since the numbers are so little, I would just get the area of each separate square and then add up all the areas together. So the area would be length times width, which would give me 4. And so all of these are going to have an area of 4. And instead of doing 4 plus 4 plus 4 plus 4 plus 4 plus 4, we can just count up. There's 1, 2, 3, 4, 5, 6. So there's 6 4s, which equals 24 square centimeters. It's probably the way I would prefer to do it. I think that that's a little bit easier. There is another way. If we would pretend that this is actually just a whole shape, if I wanted the area of this whole thing, I would just simply do length times width and get 36. But I actually don't want to carpet this whole area. I just want this part. So in order to get that part, I need to take away the part that's not really there. I need the area of this. Well, that missing piece that's not really there would actually just break into 3 squares. So I want to subtract the area of those 3 squares. And since the area is 4 feet or 4 centimeters per square, and there's 3 of them, I need to multiply 4 and 3. So I get 12, and 36 minus 12 will make 24. So you can see there is no real difference. It's just what you have to figure out what your preference is. But I always think for ones that are kind of set up like this, it might be easier to break it into pieces because finding the areas of those pieces seems like a pretty simple task.